Hello everyone, welcome back. This is Chandan and you are watching the learning field. So as you all know that we have started a lecture series for the ordinary differential equation for the exams like CSIR-NET, GATE and the SET exams, the TIFR GS exams, the uh, any other higher maths exams. Okay. So we have just upload one lecture series and just we discussed with the syllabuses of different exams like CSIR, GATE and etc. And just introducing the ODE, the definitions and some basic definitions and things facts of ODE. And we end with the different kinds of solution, that is the general solution, the particular solution, the singular solution, and like that. So, in this lecture, we will discuss the singular solution more specifically. So, singular solution is a very important thing for ODE. Most of the you all know that in different kinds of exam, just one options in the suppose if we take the CSIR-NET exams, then in one option they told about the singular solution, and if you got stuck on that option, uh, the situation in that case very bad, and you have to skip the questions for only one options. But more dedicatedly the singular solutions, uh, one suppose some questions are more dedicatedly comes only on singular solution. In these types of questions have also come in has also came in different kinds of exams. So let's start to solve the singular to read the singular solution. And I already this is the second lecture I have already said. And one thing that those who are not new in my channel, please give like this video, share with your friends, and don't forget to subscribe the channel. And in this lecture series, I will take from the basics up to the advanced of ODE, so that you can definitely solve the questions of ODE for any kinds of exams like CSIR, because you all know that recently CSIR has updated their syllabuses for ODE, and for that this course is based on the new syllabuses of CSIR. And all the syllabuses has already included this. So one more thing is also that what is in related to singular solution. We also read in this lecture that envelope, Cusp locus, what is nodal locus, what is stack locus, like that. Fine. So let's start. So first, that I have already shared with the definition, shared the definition of singular solution, says that let the ODE be given by, and the singular solution for this is first order ODE. Fine, first order ODE. So let ODE be given by xy p equal to 0, where p1 is the, or p1 this one is y1 x, that is the first order derivative, and let the solution be given as the function of x, y, and c, that is constant, equal to 0. A first order ODE which is linear in y dash is not have singular solution, in sense of singular solution being an envelope of the general solution. Now the singular solution which we called in yxc, this is the general notation. Now this line is very important. The singular solution will be the envelope of the family of solutions of the general solution. Now, if you have actually asked in any interview, or like any higher maths interview of PhD or any like that, so you may ask that what is envelope or what is the singular solution? Then you say like you say just these words. Fine. Envelope is envelope of family of solutions of the general solution, and this it will be no constant in it, unlike the general solution. Now there is a note: if the ODE is an initial value problem, and if the uniqueness theorem says that there is an unique solution in the interval around x naught y naught, then no singular solution exists in the interval, as it will violate the uniqueness theorem. Okay? Now going to the next. Now, how we can solve this singular solution? I think you all know that in BSc classes that there is two ways to solve or to find the singular solution. One is p-discriminant method and one is c-discriminant method. Now we will discuss these two methods one by one with the help of different types of examples. Right? So now see this graphical representation. This is p elimination method. Suppose these are the family of general solutions of the p total solution, that is general solution. Now we divide the two general solution and these are the c elimination method, the blue graph, blue circle. Now there are four types of locus. One is Cusp locus, nodal locus, then envelope, and then tag locus. Now we'll come the definitions of these four types of locus in the next slide. So just remember that T is the tag locus, N is the nodal locus, C is the Cusp locus, and E is the envelope. And envelope means the singular solution. So if we have find, you have to find the singular solution. That means where we find the E. Right? E is the envelope here. And this is common between the two types of methods. And simply P elimination and C elimination method means if we have given a differential equation, that is first order ODE, then we have to eliminate the y dash, that is equal to P, or in some cases C. Now in which problem we apply which process, we see by examples. And remember that for that p discriminant or p elimination method, this is a general form E t square c equal to 0. It comes one by one. And then in this case, c elimination method, we write in general that E n square c cube equal to 0. E is the envelope, N is the nodal locus, and C is here the Cusp locus. And in this case, E is the envelope, T is the tag locus, and C is the curve. Note that this E and just a minute. This E and E and C are both. This E and C are both common in two types of solution. That is P elimination method or P discriminant method, and C elimination method or C discriminant method. Fine, and these are the common portions. You can see this is the Venn diagram graphical representation. So the singular solution and the Cusp locus E and C are common in these two types of methods of solution, that is to find the singular solution. Now the definitions of envelopes, nodes, cusp, and tag one by one we read here. So it says that an envelope of family of curves is a curve that is tangent to each member of the family of some point. That means this is the actually singular solution. Mathematically, for a family of curves defined by f x y a equal to 0, the envelope is obtained by eliminating the parameter a from the system. That is, this f x y a or f x y c means this is the general solution portion. If we write the general solution in this way, first for a first order differential equation, we have to eliminate this c by any way. So, and if we eliminate and get the solution that satisfies the original differential equation, is said to be the envelope or singular solution. From the system f x y equal to 0 and del f del a equal to 0. This is the original solution and this is the first order partial differential equation with respect to a. The envelope represent the limit or boundary traced by the family of curves. So this line is also very important. So this is the definition of envelope. We comes the example now after the definition. So what is node, or this is also called the nodal locus, right? Node is a point where two branches of the curve, means they actually are the solutions of the differential equation for different values of the constant. Fine. The curve intersect and have distinct tangent. This is called a node. The locus of nodes is a set of points where the solution of the differential equation produces the curves that intersect with two different tangent. And so that means here you may note that there are this is a point where the two branches intersect and have distinct branches for two distinct tangent for two distinct actually branches. Fine. And this is also important that there two branches of curve intersect at that point. Right. Now the cusp locus. So a cusp locus is a point on the curve where the two branches of the curve meet and have a common tangent. So in case of node, actually two branches intersect each other, and in case of cusp, they actually meet each other. So this is the difference. Here we get uh, distinct or different tangent, and here in this case we get common tangent. Common tangent. And such points, the derivative is either infinite or undefined, and the curve forms a sharp point. Fine. Now, what is the tack locus? So, a tancode or tack locus is a point where two branches of the curve touch each other. That is, they have the same tangent but do not cross each other. So, in case of node and cusp, they actually meet or intersect, and in case of tack locus, they actually touch. So, three words: meet, intersect, and touch. Fine. And they have the same tangent but not cross each other. Fine. So this is a very means the difference is very nominal but very clear. You have to be very clear about each one of these. Now it is a special type of double point where the branches are the tangent instead of intersecting or meeting sharply. And now it comes to the process, the steps that how can we calculate the singular solution of an ODE. So first step number one, find YS using the p-discriminant method by eliminating p from f x y p equal to 0 or and del f del p equal to 0 by direct use of quadratic formula discriminant in the case of special when f x y p is quadratic in p. So in case of this equation f x y p, we have to apply or we can apply del f del p equal to 0 and f x y p equal to 0. In these two equations, we have to eliminate p. That is called the p elimination method. And the special case is if the differential equation is of p square, that is p square x minus p y plus y dash, this is equal to 0, or this is equal to suppose 0. So this is a quadratic equation of p. So we can directly apply the discriminant method, that is b square minus 4ac equal to 0 to eliminate p. And if this is not a quadratic equation, this is a special case, then we have to eliminate p by the given equation at del f del p and del f del p equal to 0. Now the step to substitute each value of p from found 1 into f x y p equal to 0, that is the given equation. Solve for y. If more than one solution of y found above, pick one of that satisfies the ODE. So that means if we get f x y p equal to 0 for different values of y, for solving of y, suppose get y equal to a, y equal to b, bx, anything we can get. So we have to check whether these or these satisfies the ODE. Which one satisfies the ODE, that will be our singular solution. This is the E singular solution. Find the general solution to the ODE. Now this is the case of P discriminant. Now if we have to find the C discriminant method, then we have to solve the differential equation. So in case of P discriminant method, we don't need to solve the equation, but in case of C discriminant method, we have to solve the question. So retain psi of f x y c equal to 0. Eliminate c from the equation del psi del c equal to 0 and find y dash by the direct use of quadratic formula discriminant in special case of psi is a quadratic equation of c, that is the same case. The extra thing that you have to do in case of c discriminant method, that you have to solve the differential equation, then substitute each value of c to found that psi x y c equal to 0 and solve for y. If more than one solution found out, pick one of them which satisfies the ODE. This is the singular solution. The same case, verify we obtain same E from the step 2 or step 4. So whatever the process you apply, whether it will be c-discriminant or p-discriminant, the answer should be same. Fine. That step 5 said we do not have both have to do both methods, as either method will give our same differential equation. That means that for verification you can apply the both two methods, but you don't need. Fine. Now let us see an example here. Okay. So the example is example. Fine. This is lagging. Just a second. Now, so what is the equation? This is given. The equation is suppose 9p square into 2 minus y whole square is equal to 4 into 3 minus y. Fine. So this is the equation. Now we have to solve it. So first we write this as 9p square into 2 minus y square minus 4 into 3 minus y is equal to 0. And note that this equation is quadratic. Just a minute. This equation is quadratic in P. That means we can directly apply the discriminant case, that is discriminant formula. Now if we find the discriminant which is equal to b square minus 4 AC equal to 0, what is the discriminant? So P is not present, that means 0 minus 4 AC means 4 into 9 into 2 minus y whole square 4AC is 4 into 3 minus y. This is equal to 0. That means we directly get 2 minus y whole square into 3 minus y. This is equal to 0. Fine. Now we have to compare this E square and C. So E square and C. C. C, there is no C is present. But one more thing is that in case of y e t square c and e n square c, anything that is either c or t may be or n may be absent. Fine. Absent, may be absent. Fine. In both cases. Fine. That means if we see here that if we compare this e t square c, see here c is absent. C is absent. No term. See, this is one square term. This is e term. That is e means what we get? E means 3 minus y equal to 0. We have to solve for y. That is y equal to 3. And this is e. Now we have to check whether this satisfies the differential equation or not. And t square means what? T square means this one. So t equal means y minus 2 whole square equal to 0. That is y equal to 2 we get for t. So now if we put this differential equation y equal to 2, fine. So if we put this y equal to 2 in this differential equation, then left side is 0, but right side equal to 4 into 3 minus 2. That is 0 equal to 4, which is an absurd. Fine. Absurd. That means y equal to 2 is not an singular solution. Now if we put y equal to 3, then what happens? If we put y equal to 3, then 9p square 2 minus y means 1. This is equal to 0. That means p equal to 0, which satisfies the differential equation. Fine. Which satisfies the differential equation. That means this y equal to 3 is the singular solution. Fine. We can say, we must say. Or one more thing is that we have to find first del f del y. This is equal to minus 18 p square into 2 minus y plus 4, which is not equal to 0. That means eliminating p, uh, the second equation, fine, eliminating p from what? Del f, from del f del y, and the given equation, the second equation gives p equal to 0, y equal to 2. These two, p equal to 0, y equal to 2, and we see that p equal to, we get p equal to 0 for the singular solution. That means this y equal to 3 satisfies p equal to 0. But y equal to 2 is not satisfied, this is satisfied. Therefore, y equal to 3 is the envelope, that is the our singular solution. Fine. Now we check for the c-discriminant method. So for c-discriminant method, we have to solve the question. And if we see that this equation, this is a differential equation which is Clairaut's form. Okay? Okay. So what is the solution? The solution is psi x y c. This is equal to x plus c whole square. Sorry, after solving this, we get y square into 3 minus y, this is equal to 0. So this is the solution. If you solve the differential equation, then you got this solution, fine, or from the differential equation. So you solve your at your own. You, you will get this solution, fine. Now this is equal to, we can write x square plus c square plus 2xc plus y square into 3 minus y is equal to 0. That means this is a quadratic equation in C. Therefore, we can apply the C discriminant, and since this is a quadratic in C, therefore we directly calculate the b square minus 4ac. So this, if this is not the quadratic in C, then we have to calculate del psi del C equal to 0, and by the given equation psi xy c equal to 0. From this you have to eliminate c, then you will get the solution. But since this quadratic in C, we directly apply b square minus 4 is equal to 0, which is equal to b square minus 4 is equal to 0 gives minus 2x whole square minus 4 into, what we will get, 4 into 1, C coefficient is 1, into minus y square 3 minus y plus x square is equal to 0. So this implies 4x square minus 4x square plus 4y square into 3 minus y is equal to 0. This means we get y square into 3 minus y, this is equal to 0, and we have to compare this with E n square CQ is equal to 0. See, E means what? E means 3 minus y equal to 0. That means solving for y, we get y equal to 0, y equal to 3. Now, n square means y square equal to 0. That means we get y equal to 0. And in this case, C is absent. C is absent. We already say that definitely C or what, N may be absent, but E, both the cases will be present. Fine. If E is not present, that there is no singular solution. Fine. So this is the case. That means here we get E equal to 3, fine, and N equal to 0, and T equal to 2 in case, in whole the three cases. So T equal to here, what, y equal to 2, that means T equal to 2, y equal to 2, and y equal to 3 for envelope, and N equal to 0. So we get all the E, T, C, N. but in both the cases, that is for p discriminant method or c discriminant method. Fine. Now uh, that means what we get? We get y equal to 3. This is also satisfies the differential equation. That means y equal to 3 is the singular solution. So we get both the cases. In both the cases, y equal to 3 is the singular solution. Fine. Now this is the graphical representation. See how beautiful this is. Fine. So this is the graphical representation of envelope, tag locus, nodal locus. So the solution of the differential equation that we have get, what is that? That is psi equal to x plus c whole square plus y square into 3 minus y. Now if we put the different values of C, we will get these types of graph. We will get these types of graph, or y and x are the axis. Now, these are this blue line is the tag locus. Tag locus means what? Tag locus means we already read the definition. Tangent at which the two branches touches each other. See, two branches touches each other. Fine. So the blue line and this green line shows the nodal locus. That is, what is the definition of nodal locus? The nodal locus is two branches of a curve intersect and have distinct tangent. So two branches, see, there are, this is one branch, this is one branch. This point is intersection. Similarly, this point is intersection, these points is intersection, this point is intersection. So we get two different tangents. So this is one tangent, this is one tangent. Similarly, this is one tangent, this is one tangent. Two different tangents. These are the locus. These are the what? Nodal locus. So these are the curve. Actually, see, if we see the curve, this, like this, and these types of curves. Okay, like this. Fine. So these are the two different branches. So there are two branches for different values of C. Fine. And see, these points are the red dot points are the envelope. That is the family of. Envelope means what? The family envelope of family of curves that tangent of each number of family at some point. Tangent to each member of the family of same point. Fine. So the red dots are the envelope. Now let us see an different example. Fine. Let us see example number 2, which is 27y minus 8y dash q. This is equal to 0. So we here also apply the two discriminant method. How can we calculate that? See, this is 27y minus 8pq equal to 0. So this is not the quadratic equation in P. So how we calculate the singular solution? See, first we take, suppose f equal to 27y minus 8pq. Fine. Then we calculate the del f del p. This is equal to minus 16 p minus 24 minus 24 p square, which is equal to 0. So that means we get from here is that p square equal to 0, and that means or p equal to 0. And the given equation is 27y minus 8pq is equal to 0. Now, if we solve these two equations, if we put p equal to 0 here, we get 27y equal to 0. That means y equal to 0. So y equal to 0 may be a singular solution. May be a singular solution if y equal to 0 satisfies the differential equation. Fine. So see, if we put y equal to 0, then we get 8 p q equal to 0. And from here we get p equal to 0. That means this is satisfied. That means y equal to 0 is the singular solution. Fine. Now, if we calculate the c-discriminant, so this is the process p-discriminant method. Fine. Now, the c-discriminant method, if we calculate. So, for c-discriminant method, we have to solve the differential equation first. So, to solve the differential equation, we get what? We get y dash s q. This is equal to 27 by 8y. That means y dash, this is equal to 3 by 2y to the power 1/3. So that means y to the power minus 1/3 dy. This is equal to 3 by 2 integration dx plus c star. So this means 3 by 2 y to the power 2/3. This is equal to 3 by 2x plus c star. So we can write y to the power 2/3 equal to x plus c. So that means y square equal to x plus c whole cube. So this is the solution. Now we have to calculate that del psi del c equal to 2. That means we can write y square minus x plus c whole cube. This is equal to 0. And this we take as psi, suppose. So if we take psi x y c, this is equal to sorry, what? Y square minus x plus c whole cube equal to 0. Fine. Now we calculate del psi del c. This is equal to minus 3 into x plus c whole square is equal to 0. That we will get x equal to minus c, or c equal to, sorry, c equal to minus x, because we have to replace c. C equal to minus x. Fine. So if we put this c equal to minus x in the given equation, in the given solution, then we will get, if we substitute c equal to 0, c equal to, sorry, minus x to the solution, then we get y square equal to 0, that is y equal to 0. So that means y equal to 0, what is the given equation? Equation is 27 by minus 8 y dash q, this is equal to 0. Is satisfied? That means y equal to 0 is the singular solution. And y equal to 0 is the singular solution. So I think you understand, you'll understand this thing. And this is the graph of this last question. So what is the 27y minus 8y dash q? This is equal to 0. After solving, if we put different c value, then we get these types of graph, this one for different types of graph. And these red dots are the singular point, the envelope of family of curves. These are the family of curves where they touches in that point, that is in the origin. That is, we already get y equal to 0. See, that means y equal to 0 is the x-axis, which is our singular solution curve. Fine. Now we see another example, which is given by example y minus x into 1 plus p minus p square, this is equal to 0. Fine. So this is a equation example. So we check first, say let f is equal to y minus x into 1 plus p means dy dx minus p square, this is equal to 0. So we first check whether del f del y is equal to what? 1, which is not equal to 0. As this equation is quadratic in p square, therefore we can write is as p square plus x xp minus y equal to 0. So b square minus 4ac equal to discriminant equal to b square means x square minus 4 into 1 into x minus y is equal to 0. That means we get x square minus 4x plus 4y this is equal to 0. That means we get y equal to what? X minus x square by 4. Fine. We get this one. Now, if this satisfies the differential equation, then this will be the singular solution. So, if we can put here, so what is the value of y dash? Y dash equal to 1 minus x by 2. So, if we put that means this is the p. So, check whether this satisfies or not. So, y means what? Y means x minus x square by 4 minus x into 1 plus p means 1 minus x by 2 minus 1 minus x by 2 whole square. This will be 0 or not. X minus x square by 4 minus x minus 2x plus x square by 2 minus 1 plus x square by 4 minus x. So x minus x square by 4 minus 2x plus x square by 2 minus 1 minus x square by 4 plus x. So x square by 4, x square by 2, x square by 2 cancel. Fine. X plus x minus 2x cancel. This is equal to minus 1, but this is not equal to 0. That means it does not satisfy the given ODE. That means what? Singular solution does not exist. So fine. So see, we here we discuss what is the singular solution. Solution different kinds of locuses. Fine. And three different examples. Three different example. That is P discriminant. Sorry. In this three discriminant, we see three different problems. P discriminant, C discriminant, and also SS does not exist. And how P discriminant and C discriminant verified can be verified, this I already showed in the first example. Fine. So this is a very beautiful video and very beautiful topic for ordinary differential equation. You have to know this. Fine. What is singular solution? How can you calculate the singular solution? These are very important things. So this is the second lecture. I am going to end this lecture here. I don't know how long is the lecture because I said that 38 minutes. So sorry for that, but singular solution is very important topic. Okay. So if this lecture is helpful for you, then definitely like this video, share it with your friends. Don't forget to subscribe the channel. Thank you. Bye.